Hello friends, myself R.D. Mahajan presenting my video on Z transform. Let us solve the first problem. Find Z transform of sine of n pi by 2 plus pi by 4 with the condition n greater than or equals to 0. And as n greater than or equals to 0, we use the standard result to find Z transform. And first we expand that term sine of n pi by 2 plus pi by 4 as sin a plus b, as sin a cos b plus cos a sin b, and therefore it is sin of n pi by 2 into cos of pi by 4 plus cos of n pi by 2 into sin of pi by 4. Once again I will repeat, sin a plus b is sin a cos b plus cos a sin b, and then using the standard result, cos pi by 4 is 1 by root 2 into sin n pi by 2 as it is, no change. Cos sin pi by 4 is also 1 by root 2 and cos n pi by 2 as it is, no change. Then taking 1 by root 2 common from this two term, we get 1 by root 2 into remaining terms are sin of n pi by 2 plus cos of n pi by 2. We call this equation 1. Then taking Z transform on both sides, Z transform of left hand side is equals to Z transform of right hand side, and therefore we get Z transform of sin of n pi by 2 plus pi by 4 as 1 by root 2 is constant term, we take outside as it is, and Z transform of individual, therefore Z of sin of n pi by 2 plus Z transform of cos of n pi by 2. Applying standard result, just I have discussed this result for Z of sin omega n. Here omega is pi by 2. Therefore, it is equals to 1 by root 2 as it is, no change. Z transform of sin omega n is Z sin omega. Omega is here pi by 2 divided by Z square minus 2Z cos omega. Omega is here pi by 2 plus 1. This is the Z transform of sin omega n, and Z transform of cos omega n is Z into Z minus cos omega cos of pi by 2 whole divided by Z square minus 2Z cos omega cos of pi by 2 and plus 1. And we know the standard values. Sin pi by 2 is 1, cos pi by 2 is 0. Therefore, using that values, we can simplify it further. 1 by root 2 sin pi by 2 is 1, therefore it is Z divided by Z square cos pi by 2 0, therefore this term becomes 0, and plus 1, and plus Z into Z square, Z into Z, we get Z square cos pi by 2 is 0, that term becomes 0, divided by Z square cos pi by 2 once again 0, this term becomes 0, and plus 1. Therefore, as denominator same, we can rewrite this as 1 by root 2 taking LCM as Z square plus 1. In numerator we have Z and plus Z square. This is the required answer. Remember the two steps. First step is expand it by sin A plus B, and then take Z transform on both sides. Apply Z transform of sin omega n as Z transform of cos of omega n. That two standard results to get this one. Next example, find Z transform of cos square of 3n. Therefore, we don't have any standard result which we can apply directly here. Therefore, first step is to simplify it by a standard result from trigonometry. We know that cos square theta as 1 plus cos 2 theta by 2. Therefore, that cos square 3n we can rewrite as 1 plus cos of 2 times 3n. Therefore, it becomes 6n and divided by 2. Then Z transform on both sides. Z transform of cos square 3n means Z transform of right hand side term 1 plus cos of 6n by 2. It is equals to 1 by 2 we can take outside as a constant term. Z transform of the first term 1 and Z transform of the second term cos of 6n. Then applying standard result we get Z transform of 1 is Z upon Z minus 1 and Z transform of cos of omega n is Z minus cos omega. Cos of omega is a 6, therefore cos of 6 divided by Z square minus 2Z cos of omega means 6 cos 6 and plus 1. This is the required answer or required. Next example number 3, find Z transform of sin cube of 2n, condition n greater than or equals to 0. And to determine its Z transform, we take the help of this standard result from trigonometry. Sin cube theta is 1 by 4 times 3 sin theta minus sin 3 theta, and therefore applying this we get sin cube of 2n as 1 by 4 3 times sin theta sin of 2n minus sin of 3 times theta 3 times 2n 3 to the 6n, and then we can take Z transform on both sides. Therefore, Z transform of the left hand side sin cube 2n nothing but 1 by 4 outside, Z transform of 3 sin 2n minus sin of 6n. Here we take the help of that standard result. Z transform of sin of omega n as Z sin omega divided by Z square minus 2Z cos omega plus 1. Z transform of that sin cube 2n is equal to this 3 also we can take outside, therefore it becomes 3 by 4 Z transform of sin 2n minus 1 by 4 Z transform of sin 6n, and then applying the standard result we get 3 by 4 as it is. Z of sin omega n is Z sin omega, omega is here 2, and therefore Z sin 2 divided by Z square minus 2Z cos of omega cos 2 plus 1 minus 1 by 4. Again Z transform of sine 6n. By the same result we get Z sine omega, omega here 6, divided by Z square minus 2Z cos 6 and plus 1. We keep this as it is, and this is the required value of that Z transform. Therefore, in this I have discussed 3 simple problems where I have used Z transform of sine omega n and Z transform of cos of omega n. In my next video, I will discuss some more examples on that standard result. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my all new videos, you have to press the bell icon. Thank you. Thanks for watching.